So thanks for coming for the talk. So we have a topic on how to turn your phone into low-cost IMSI catcher device. So basically, the name is a little bit confusion. So we are not building an IMSI catcher itself. It's about how you could detect IMSI catcher. But today we will also have something new exactly, how you could really turn this device into something weird. And we'll try to show you how we did with Samsung Galaxy S3 and what is the possibility you could do more. So myself, R Borgaonkar, I work as a researcher in TU Berlin. Since last 5 years, I am passionately curious about mobile communication networks, works on different security aspects. And he's a Swapnil Udar. He works in Aalto University. And he works as a master's student right now. So we are college friends from India actually, and that's what we hang out and work some new stuff together. So let's give you an overview of what I'm going to talk about. So how many guys in Black Hat actually, or how many guys haven't seen the slides from Black Hat? Okay, not much. So let's go. So I will just give you what exactly the unsolved privacy issues with GSM and 3G, especially in cellular communication network, and what exactly we want to focus here. I mean, that's what motivated me at least to build this tool and what help this gives you. And then we built a Darshak Privacy Framework. So why we call this framework, I will get you to the point why it's needed to be like build something like similar platform. And some of the use cases of this tool, like in a daily use, how could try to use it and try to detect some weird happenings in your cellular networks. Maybe we don't know it's like a weird configuration, or maybe something is bad happening on the network side. And then future work, that's what we're planning with this tool, where we want to take it further. So before going to the outline, I just wanted to see what is the problem actually. Like we are seeing this fake base station problem and how far we are going with this problem. So there was some, from last year, there are some articles coming about. That was the first one. Chinese cops cuff 1,500 fake base station spam raid. There was also one more actually. The pseudo base station hides the cars and run the street to cover mobile phone send SMS fraud. So in China, there was some recent report actually, and this was true because I also work in academia, so we review some papers, and I met some Chinese professor and he told me, yeah, these reports were true. So what does happen? In the night, some car come like outside of your building, and suddenly like middle of the night, you get some SMS. Hey, your bank credit is low, or your bank seems to be hacked. You really want to check, reply with this with your credit card number or a PIN code or access code or something. So this is basically a spam SMS you're getting nowhere out of actually in the night. And some people just replied blindly, and this could be your credit card number or whatever it is. So there are ways actually, this is the new kind of phishing attack with those spam base stations, because they are trying to exploit the GSM weak links. And these boxes are getting pretty cheap nowadays. So you can buy from China like a $1,000 something, or 1,500 at least says. I mean, yesterday we had to talk about greedy base station. So he taught us like you can build yourself same kind of base station to send SMS. Like he yesterday has a demo like he can spoof some SMS or something like that. So this was the one factor, and this is we are seeing in practice happening. So how do you detect actually as an end user that you are a victim of such kind of things? Second is targeted attacks, which we also saw witness after I gave a talk in Black Hat. This time, then immediately one company said, okay, they also figure out some fake base station in the United States. And they also gave a map, like in which state they figure out there are some fake base stations. How many guys know this company called GSMK? It's a German-based company who provides a crypto phone. Yeah, some guys knows definitely. So they claim that their clients discovered that these are the fake base stations. Pretty good. I mean, and FCC also said that they're gonna investigate this matter, that how many fake base stations or maybe the illegal base stations trying to intercept somebody's communication. So this is really ongoing problem, and at least not ongoing, but we might see in future something is problem. So how to tackle with this problem? So, and what they claim by all the media, some facts are true, some facts are not really true. And that's what I want to highlight, or that's what I put into this slide, because with some methods, I try to show you that, okay, this might be correct, but this may be wrong. So they are not sure that this could be a fake base stations, because this is pretty challenging task. And we don't know how skillful the IMSI catchers are actually nowadays. Considering the existing IMSI catchers, how skillful they are, how smart they are to detect some surroundings, we don't know. But of course, prediction helps. And the solution so far which we have, as I already said, so this is at least going viral in the media. So this is their tool actually. This is a baseband firewall which tried to tell you that, okay, your mobile network standard encryption has been turned off. Possibly this could be a IMSI catcher or fake base station, right? Yeah. That's their one method of telling that, okay, you might be under some interception. Maybe some FBI or maybe any bad agency is trying to intercept you. And this is our tool actually. And if I follow their method, if you see these red dots, and actually those are the encryption. So how many calls I made, it tells me that some of my calls completely without having any encryption, there was completely plain text over there. And actually with this concept, I can say that I was also on a fake base station, but this is not true. Because this has various technical reasons why this is happening in the real time. And actually, also I tested last 2 days, I was testing my tool also here in this same place. Of course, we did not find any red dot, but there were plenty of weird behavior. And of course, this is due to the load on the tower. We'll go so far. So this is the solution we have. This one is free. Of course, this costs you to buy a special phone. So let's talk about what exactly the problem, I mean, with this mobile space, why we are not able to detect such kind of attacks or tools. Everybody has a smartphone, I mean, Android, you have a BlackBerry, or maybe any other operating system, right? So everybody's trying to say you are secure, your data is secure, nobody gonna intercept you. Of course, you can argue with me that you have end-to-end encryption and you are safe. You believe that there are only two-way communication between your devices and nobody gonna intercept, okay, you are pretty much secure. Then we have efforts from all the researchers, startup companies who are selling a new secure phone, end-to-end encryption or whatever it is. Then devices are also good. Everybody's trying to say. Networks, if you go to any operator, say that we have the best encryption standard. I mean, the up-to-date encryption standard they are using, everybody's claim. You can ask any operator. They say they are trying their best to provide security level to their customers. But still, when you have targeted attacks, what happens? And some of the CEOs also trying to say that, okay, when you have a targeted attacks, how do you detect? And this is the problem. Because attacks happen, your conversation got recorded, and you don't have any trace. So how do you do that? So one way they try to do such attacks is IMSI catchers, first of all, or who try to do these attacks. These are the legal entities or illegal entities. I'm not talking about lawful interception here. So I hope you guys know lawful interception. Every country has a law that for some time of period, at least 1 year or 6 months, your all calls, SMS are legally recorded. This goes by law. I don't know exactly what the law is in UK, but I live in Germany. So Germany has 6 to 1 year like a variant. Also, I was living in Nordic countries, so they also have a law. At least they store for 6 months. Each and every call is recorded. So this is different task. So they do for legal purpose. And illegal entities also do that. So how do they do actually? So this is the mechanism we're going to see. And what are the methods of doing? Are they really compromise your phone, like pushing some malicious operating system update and just compromise everything and sends back data to their malicious server? We don't know. And we'll just highlight what are the ways of trying to do that. So let's see targeted attacks, just to divide what exactly they do. First is IMSI catchers that I hope everybody knows. Like you have seen some Hollywood movies, the black man comes and he has all this spying equipment tools. He say, okay, this is the guy, track him, and let me know what exactly he's talking. They just press the button and you see what he is talking right now, sitting in the car. So these are the typical IMSI catchers. There are two methods, at least in IMSI catchers. One purpose is, of course, location, to try where this guy right now, like if he's in office building right now, or maybe whether he's in this area. That's one purpose. Second purpose is real interception, real time. They wanted to record your call. It may be a passive, it may be active, depending on that. And then there is also other method. Some companies try to sell you solutions. So this is one Israel company, the Pegasus. I'm bad at the pronunciation, but this might be one Israel company. At least they claim some of the documents which has been leaked over the internet. They claim that they push some compromise update on your phone, which has been signed and properly encrypted with the OTA keys. And now who give them OTA keys? That is a real question. Either they really do some awesome research to find out what exactly they can exploit to push the firmware on you, because legally only the Android or maybe the Samsung is allowed to push you the firmware, right? So I don't know what exactly method they do. At least they claim that they have all the tools to push these updates. I mean, what I collected document I have. So this was actually their catalog, which was released, at least what this says. maybe SIM toolkit they have, and same kind of mechanism we already saw on NSA catalog, which was released, and the same mechanism it was mentioned. So at least it matches with the evidence. This is possible. Now, how do you retake those kind of attacks, which are really happening, targeted attacks? And one point nowadays, IMSI catchers not only GSM, they are also supports 3G. So this was from a Gamma company, and they said, okay, they also have a 3G GSM tactical interception. Even though they say 3G, it's tried to downgrade you, but some are still claiming that they have a 3G one also. It might be depending on femtocell, and they are true. Then normal question, okay, this is about targeted attacks, so you are not the victim, so you just travel here and there. But as a normal human being, at least I use mobile phone. I want to see whether my last call was really encrypted or not. How do I see? So there is no method on your Android phone, Android phone or Apple phone or even BlackBerry phone. There is no tool which you can see that whether the last call was encrypted. Of course, if you are using a SIP provider or you know that your call is always on Wi-Fi, so they might be secure. But what about if you are using cellular communication? Is someone tracking you? There are tons of ways, some known ways, some unknown ways to track you by sending some silent SMS or maybe other mechanisms to locate you, whether you are in the city or which country right now you are. So anybody can do by sitting at a PC, right? So how do you try to verify if somebody is really tracking me, besides legal entities or lawful interception? And how I try to know, this is really hot problem. How I know that I was a victim of IMSI catcher attack, that my phone was compromised? Yeah. And how do I know that my mobile phone supports all the up-to-date security standards, algorithms, even my operator also? So there is no way to do that. And that's what actually I was trying to find out. As a researcher, actually, we were building a tool, okay, how do I see? There are some phones, actually, old BlackBerry phones, some old Nokia phones shows you that whether your call was encrypted. But nowadays, nobody shows you. I do with this Osmocon phone or laptop, but it's like time consuming for me. Like I cannot take my laptop and always see, okay, I go to London now, let's see how the network is encrypted or not something. So this is like time consuming, I cannot do. So I just wanted to have some phone which can I do myself. So that was the kind of motivation to build this framework for me. Then we also had one more problem with the 3GPP or the whole mobile ecosystem. So what the standard says, so 3GPP is the standard which try to build a protocol like every manufacturer should follow and build their device by this guideline. And this is a document for every manufacturer. A phone manufacturer says there has to be a ciphering indicator, and this has to be a mandatory or optional. Of course, star it means depending on some cases, but this is a mandatory feature. Every smartphone which has been sold by Samsung, Apple, has to have this feature. That's what the standard says. It used to follow old times by Nokia, by old BlackBerry phones, old Sony Ericsson phone, early days on GSM. You used to see like such kind of message before you make a call. Nowadays, you don't see. You see this kind of message now on GSMK phone, which has been sold around $3,500. Pretty expensive. So you have this kind of feature, but not on every phone. Actually, this has to be supported by every phone. Then there is no API for Google for this one. So this was the indicator, and this was the issue actually. But after the Black Hat talk, the Google guy also contacted me. Hey, we are a little bit interested. Would you like to share some result with us or want to work with us? And now the one guy from Niels from Google, he commented on this issue 2 weeks back. Okay, we are ready to build this API. Anybody wants to help us? So if you go on this link, actually, you will see that they are interested now to put something. But they said that this will not be enabled by default on Android Stream. So user has to manually do something to activate it. There is a reason for that, because operator doesn't like to see such kind of thing that their network is not secure. So there is some politics kind of going on. And the best method actually, whatever the question I ask you, either you are a victim of IMSI catcher or not, how do you really find out? There is a really golden rule to find out this one. And this is, some smart people, old generation people still use it. That is the prepaid SIM card. I give example. If I'm a guy actually who is under the IMSI catcher attack, what happens? They try to intercept me, right? It means that my call is not going to the real network; it's going on a fake network, and they are allowing me to talk free because it's not a real network. So if you have a prepaid SIM card, have a £5 balance on you made a call and your last call was free, you did not get a message that your balance remaining 3, it means that something is going wrong. Easy thing. But nowadays, everybody has a flat rate. Everybody has a data flat rate. You cannot really see what's happening with your network bill. That's the simple way, at least people say, to find out whether you are secure or not. So that's what we try to build then to figure out with this Darshak framework. So our goal was to make a research platform to collect the GSM and 3G security related data. So anybody having this phone can use it. You don't need to do anything, just make normal calls, SMS, you just collect some security parameters, you can upload data to our server, and we're going to release all the data to all the research community. So we also have one similar kind of tool, which is the GSM map from SR Labs in Berlin, but actually they don't release any data, and data is really vital for research, at least in mobile space. And now our goal is to release this data by collected all the user, and second is easy to use for everybody, so you don't see anything. This is always running in the background. So now Swapnil will just introduce you what exactly this Darshak framework and what features we provide.
Thanks, Ravi. Enough with the problems now. We'll see what solutions we can provide to counter all these problems. Well, to counter all these problems would be a very big statement. We'll try to just find out the very basic things that at least the user will aware of what's going on in the background, and provide a more transparency to the user from the network, mobile networks. So this Darshak, it means actually in Indian language is an indicator. So in this case, it means an indicator of security parameters of a mobile network operator. Well, Darshak, there are so many limitations in Android APIs. They don't provide APIs to like whether your call is encrypted or not, whether your operator is refreshing your IMSI regularly or not, whether they are authenticating your every calls or not, which they have to do, they should do. But and all these were the limitations in Android-based framework. So we tried to get the raw logs from the baseband, so that baseband logs all the transactions between your baseband and your mobile device. And this baseband logs has all the details of whatever the communications happens between network operator and your device. So okay, with this in mind, we try to develop a framework which actually does basic 4 things. Like it detects like whatever the suspicious activity happens in the background, whether your call is encrypted or not, and all those things. If it detects something suspicious, it notifies the user. It doesn't do anything on behalf of the user, but it just tells the user, hey, this is something bad happening, or it seems to be suspicious. And this third is intelligence, like the IMSI catcher devices. There's so many IMSI catcher devices spooks many parameters from the mobile device, like your cell identity, your location area code. But there are n number of parameters which they may not be changing, or they may not be spoofing as the mobile network operator. So we can track those parameters and see if there is some change in the parameter from your mobile network operator, and then we can notify the user, hey, there's something changed again. And also another thing is the collection of data, because there is no single source of data where you can find the data from all the mobile network operator in your country or all over the world. So this Darshak framework can help you to collect the data and share it with everyone, and who is want to analyze on the data further, they can do it. And we're making this data free and open to everyone. So with this framework in mind, we implemented few features. This is like a GSM and 3G networks. So whenever you make a call, receive a call, send or receive an SMS, it actually tracks the security parameters which were exchanged between mobile device and your base stations for that transactions. And from that data, it tries to get like if the authentication is done, encryption is done, what was your IMSI number for that transactions, and all those details. It also captures the silent SMS and notifies user. And silent SMS, as many of you know, silent SMS has a special kind of SMS which when received, it doesn't notify the user, but the recipient mobile just rejects the SMS. However, it sends a delivery message to the sender, so that the sender can spy on you at least, or see that your mobile is on or off, or it can also be used for your location tracking also. And the recipients will never know about it. It's an alert whenever the your call is not encrypted, and displays all suspicious activities that we have discussed. Okay, these are the few technical details of the Darshak framework. Right now, Darshak framework can only run on only Samsung S3 and S2 devices. The reason is that the baseband logs that we're collecting, it's only possible right now only for the Intel baseband devices. So we have not tested on any other devices, and we have no way to get them right now. And the Darshak framework is based on the X-Goldman concept. X-Goldman is a tool which it can be used, which is really a very great tool actually. It helps you to capture your mobile device communications in a runtime. But the limitation with the X-Goldman is that you need a Wireshark to decipher all the packets. And you cannot, to run Wireshark, you'll need some laptop or some desktop computers, and you cannot carry your laptop everywhere to just see the communication, what's happening. So and the improvement over the X-Goldman is that the GSM map application. GSM map applications is an Android application which collects the data from the user. It provides a means to make a call to some dummy number for fixed number, and then that fixed number makes or sends a call to you, and it collects the data, and the user has to send this data over the network to their servers. That they haven't made this data available to everyone else, but they have a application, or that they have a website called gsmmap.org, where they have a map of the whole world, and then they have indicated like what is the security level of mobile network operator in that region. But it's the data they have collected is not open to everyone right now. So with these two, X-Goldman and GSM map in mind, so we thought that takes the runtime of X-Goldman and the accessibility of GSM map. So we build this framework called Darshak, which tells you the security capabilities of your mobile network operator runtime, so you don't have to carry a Wireshark everywhere. And yeah. So whenever, there's another thing is that whenever you receive a silent SMS, it tells you like who is the sender of who is this sender. So that's pretty neat actually. It also classifies what kind of encryption algorithm is used in your call, like A51, A52, A53 in case of a GSM, and a UAE1 in case of UMTS or 3G. It also tracks your TMSI number in every transaction, so you can verify how TMSI number is changing, because TMSI number has to be changed regularly so that no one can eavesdrop your call or no one can track your location. And the network operator does not do it very regularly. But as an end user, you can track like how frequently your TMSI is getting changed. In case of an authentications, whenever a mobile network operator does an authentication, in case of an GSM, it sends you a random number, and then which you have to encrypt with your secret key, and then sends over the network to the mobile network operator, and then they verifies if the right user or not, which has to be done for every transaction. But mobile network operator they do it, but they don't do it regularly. EUTN, the same EUTN is an authentication token they use in case of an UMTS. Okay, how to get an application? So we already released the source code of an Darshak applications on GitHub, under a GPL license, so you can go modify it, fork it, and change it. And the Darshak application is also released in a Google App Store also, and which is of course free of cost. So you can download and give it a try. Okay, this is how the application works in the background. Well, in applications, like every 30 seconds, the applications goes in the background and gets the baseband logs. And once they get a baseband logs, it scans for the silent SMS, paging request, and system information request in that baseband logs regularly, every 30 seconds. And whenever you make a call or when you receive a call, it acts as a radio event, and then it also looks for if there is an authentication packet is there, if there is a TMC relocation request is there, and similar things related to your radio transaction. Okay, Ravi will cover the GSM background. Thanks.
So this was about how exactly the app technical methods we collect. But now, to interpret or analyze this data, so we need to know more exactly how the GSM behaves or 3G behaves, or what is suspicious, what is not suspicious. So that is really important. Like on his previous slides, he says it shows TIMC. So what exactly this TIMC means, what is needed to be updated every time, and why. So in GSM, we know some problems. So I mean, I just don't want to explain in too detail. I just try to make it in simple words. So we know everybody knows base stations. We see in every building and every part, right? And then we have a mobile phone. This could be any phone. So this phone has a SIM card, and SIM card has one unique number. When you buy from a store, it's called IMSI, which is called IMSI. That's what exactly the first word stands in IMSI catchers. This is about your unique identity in a SIM card, which bind to your identity with your passport number, social security number, or whatever it is. And this always sent first time when you connect your phone to the network. And since this is really important or vital identity, the network operator, the design has been in this fashion that once you authenticate, they will always use this TIMC number for subsequent calls or something, so that nobody can trace you that whether this is the same guy who is making a call. And that's why this TIMC always has to change after 2 or 3 calls, or depending on which location area you are going. So maybe from West London to East London you are going, your TIMC has to change. If you don't change, anybody can trace you if he knows your TIMC number, at least try to locate you. So that's what's important. But that was the thing actually. But now, what are the problems we know in GSM? So yesterday we had a talk about greedy base station. So he implemented everything, he showed everything, but why this was possible, he was able to do that. Why he was able to intercept iPhone's call or data connections. First, we know that there is no mutual authentication between GSM and between the tower and your mobile phone. So your mobile phone is always authenticated, but mobile phone doesn't have any capability to authenticate whether this is the right base stations or a wrong base station. So this flaw is classically, we know, this is from last 20 years, not has been fixed. It's difficult to fix because we cannot upgrade all these things. So that's why we see the attacks, fake business attacks or man-in-the-middle attack, like same attacks yesterday, or the IMSI caches work in the same one. Then we have a weak algorithms. There are some conspiracy theory that they thought they were designed to be weak actually. We don't know, but there were plenty of recent articles came actually saying that they were designed to be intercepted. We don't know, but A52 was broken. Mathematically, it was really weak actually. A51 was also weak. The cryptographers really showed that theoretically it's possible to break. But now in last 5 years, we have a really advantageous, we really have a speed up the process to break A51 passively. So some guys, the SR Labs also released rainbow table, so you can really decrypt the A51 calls passively. Also, NSA catalog shows you that they have the capability to decrypt A51. You can also go on Google, just catch IMSI catcher, A51 capability. You will see many companies who are selling A51, how to decipher the A51. So you can buy those devices nowadays to do A51 encryption. So this is due to these weak algorithms. Then the main problem with this whole mobile communication, this also happens with LTE, also 3G, and also GSM. The base station has a fully capability to tell your phone what to do or what not to do. Your phone cannot decide anything. If base station says, don't use encryption, don't do authentication, it just act as it is. You don't have any capability to do anything. So full power, you have to blindly trust the base station. That is the main problem in whole communication architecture, any communication technology, 3G, 2G, or LTE. And that's what people are trying to argue. I can give you a reason why this was actually. Because when the guys in France, they decided to design this technology, GSM 3G, 20 years back, they thought the active attackers are not going to possible. They never considered threat model as active attacker while designing the system, because they thought nobody going to have these equipments to catch or intercept something, but now this is happening. And now it's difficult to fix all these things because every technology has a backward compatibility. So you have a legacy system, so it's difficult to fix. So this problem is going to occur even for LTE now. Might be. Of course, you cannot have a fake business attack, but this kind of issue will be there. Then we have a plain text over there. Of course, if you don't use proper encryption algorithm, you're going to have a IMSI and TIMC capture easily. This always happens. You can anytime, if you have any RF tool actually to intercept communication, try it, decode with a Wireshark, you will see plenty of IMSI and TIMC numbers, but you cannot recognize which belongs to whom. But this is always in the air. Then there is no authentication for IMEI. Yesterday also the greedy base station guy also told you like there is no IMEI authentication, and you can easily see and spoof those numbers. And lastly is local regulations. Nobody tried to force that. Everybody knows GSM, so why don't they upgrade the algorithms? They are still using weak algorithms. I will show you some of the data I collected in last 2 days while staying here actually about UK operators, and you will see what is the really difference between what exactly available in Germany, what exactly available in US, and what is available here, and why they did not upgrade their systems. So this is also a problem about local regulations, why the government is not forcing to use the standard algorithms, right? So GSM is badly broken. As I yesterday said, we also saw a real demo actually. Only one point is important actually for me to say authentication, and that's what our tool is trying to do actually, because mobile originated call and mobile terminated call. There are two technologies. What does it mean? Mobile oriented means when you make a call, and mobile terminated when you receive a call. And there is really difference exactly how these two calls are behaved for authentication and encryption. So, and mobile originated calls are always authenticated. Why? Because the telecommunication companies wants to see really you are paying for money or not, because they charge you for every call, right? So they have to see that whether you have a balance to make a call. But when you receive a call, those calls are free for you, right? So there is no way, I mean, for them, there is a way, I mean, there is a really good option not to authenticate. In old times, 15 years back, when there was charge for incoming call also, they were really authenticating both calls. So you see, business changed. Now you have incoming free. Now you don't have also security settings for your incoming calls. So incoming calls are easy to monitor, easy to spoof your incoming SMS, and those attacks also shown. So let's see use cases actually. So I talk a lot about what exactly the problem, but let's see what exactly how Darshak shows or try to identify those parameters. Can I have this phone? Continue. I make a call, you can show there.
Okay. So here's the screen. You can see like there are like two entries that we see in the image that which is taken today itself. There is now there you can see the date and then the network type, which is GSM. Then the event is like you make a call, you receive a call. When the authentication is done during this time, it shows green, so means the authentication was performed for during this radio event. And there is an encryption. Well, encryption is I don't know how it looks to you, but it's in orange color. It means the authentication was performed, but the authentication was A51. So as Ravi earlier explained, that A51 can be broken. So it is an encrypted call, but it can be broken with sophisticated devices. Yeah. And when you press on one.
So I try to make one missed call to this device, and let's see the event will pop up exactly what my last call settings were actually.
Exactly. And one more thing is like for every transaction that we've seen in earlier screen, you can see like other details like whether the A51 is available, A52 is available on your mobile device, what is your IMSI number, what was the random number that used during.
So don't try to take my number, I mean, otherwise you will spam me again. So.
I will wait for pi.
Wait. So sometimes it just takes time because the Android, when it's in sleep mode actually, sometimes it just missed the event actually, and this was flaw. We fix it, but it's still sometimes it's difficult with Android, because classically we collect all the raw log with the baseband, and sometimes it just with the permission. Of course, device needs to be rooted, and sometimes some apps try to tweak in between actually. Okay, so looks like it's not working, but I will continue with the second one. So we clear the logs. As I said, sometimes it just, so I go with, because app is always on in the background, we just created a flag so I just now reset the app now, and I make one missed call. Yeah, okay. Now there should be. Do again. Anyway, so as usual, so demo happens like this, but I will continue. So he will continue with the demo, and I will just go with the slides. Can we have slides, please? Okay, so he will just check the file. So what exactly it does actually, it tries to record all the calls and show you what's happening. So if you see this symbol, so this means this was the outgoing call, which was not using any authentication or there was no encryption actually. So it shows you red dot 21. Of course, it doesn't alert you. It alerts you if the operator is using A52, which is the algorithm every operator should get rid of from the network. So it gives you a pop-up alert, okay, somebody's using A52 and this looks pretty suspicious now. Or maybe when this pop-ups, at least right now, we did not put any notification for you like, oh, last call was not encrypted, so something was wrong. Because there is a reason for that. When you are in a congested area, when the base station doesn't have that much, I mean, it's have a lot of traffic, it just don't do any signaling traffic. So it might be just a misconfiguration in the base station or some technical glitch in the base station. This is causing. So I cannot be really sure. That's what we are just using as an indicator. We are not popping up a message saying that, oh, this looks like a suspicious or something.
Yeah.
This one?
Switch back to the phone, please.
Oh, yeah. So now we have the event for the GSM last call which we made, as it said. So it shows you exactly. So network operator was requesting to start ciphering. So I was using, so this phone is right now on a Vodafone network, and the Vodafone network says start encryption. It was using an A51, but technically this was actually somebody can break if they can intercept your call passively also, even actively also passively. And it also shows you what exactly the random number used. And why I collect this random number, because some operators are really weird actually. These random numbers are created based on the hardware-based token on every base station. So there is really proper hardware which generates those random numbers. So when I collect this data for different operators, like last 2 or 3 years, I collect data, and you really see weird pattern. Those are not really random numbers. So this might be a problem from operator side. So that's what we collect these numbers also, if somebody is really willing to submit the data, so we can have a more numbers actually to show that whether these are not really random numbers, because everybody do research on random numbers with a Linux system or something, but in mobile communication, nobody tried to focus what's going wrong on something. So this was the first call. So we go with the second one, but okay. Now we have about detecting silent SMS. So instead of can we have a slide, please? One more time. Yeah. So detecting silent SMS. So you continue. I try ready with the demo.
Okay. Well, there are numerous type of silent SMS are there. Like this is a type 0 SMS, and standard specifications that are whenever you receive an SMS, your mobile should send a delivery message to the mobile network operator. But in the case of a silent SMS, whenever the recipient receives a silent SMS, the message gets discarded, and there's no trace of the silent SMS. However, it sends a delivery message back to the sender, and it does not show any notifications for the user. And this flaw has been exploited by many police agencies and illegal entities to track users. And also, when you receive a silent SMS, your current locations gets updated on your base stations, and that can granularly track your current location without even notifying the recipient. And there's a tool called Hush SMS tool, which we used for during our testing phase. The Hush SMS, from Hush SMS, you can send 3 types of silent SMS, like ping 3, ping 4, and there's a type 0 silent SMS. Yeah, thanks to Hush SMS.
So this ping 3 and ping 4, so if you go on next slide now, we have it definitely. So what is this ping 3, ping 4? Actually, these are basically a type of message your phone should discard. These are the binary SMS which will never go to your inbox. Like you will never see notification, okay, I received. But these are like a binary SMS which comes to a SIM card, for example, or any special multimedia message which just comes and you never see. Actually, this happens. Buy a new SIM card, put you into a SIM card. Sometime on Android or iOS, you get a message, SIM data refresh. Actually, these are those kind of messages. But you don't get those messages like immediately. But those are the messages which also try to implant SIM toolkit on your SIM card to collect some information. So these are the 2 types we try to detect. And one is type 0, which is typically used by agencies to track you, which has a PID 64-bit number. And this, nobody detect anything. I mean, basically, I sent 10 messages to this device. It never gets alerts. Screen never gets beep or anything. It just background happens, and they know this guy is right now in this area. It just happens right away. So we also detect this one even. So you see here, and we also show you exactly who was the last sender number. If you know some of the numbers, actually you can really Google and try to see which belongs to whom. I mean, of course, you will not get any information, but this is just helpful for you. So we'll have a demo for now, silent SMS. So we try to send type 0. There was a problem with sending a type 0 actually, because right now we are using a T-Mobile. I have a T-Mobile SIM card. I also have a Vodafone SIM card, but it's from Germany. So, and I tried to send on a Vodafone actually here by local SIM card. So yesterday we got 2 local SIM cards from here. And actually it turns out that the UK operator blocks those SMS for sending, only for sending, but they do allow to receive those SMS. This depends on every country. So in Germany, Vodafone do allow. Yeah, Vodafone and T-Mobile, they do allow actually, but T-Mobile completely blocks. So if I send you SMS type 0 kind of, you will just get a blank SMS. Only blank SMS, no text, for example, something like that. So now I will show you with the type 0 and also with type 3, ping 3 and ping 4. So now this is just a phone as it pop up. I try to send now ping 3 first, because ping 3 will be just to show number phone number. What's the number? Vodafone. 49 174761. So I sent one SMS to this mobile phone now, which is type 3. Now let's see what it pop-ups on the screen. So this was the pop-up from Hush SMS, which also tried to detect. There was one more tool, but this detects only ping 3 and ping 4, which gives you the same alert. And as I said, type 0 doesn't pop you. I mean, not allowed to send from my T-Mobile SIM card to this one. So what I try to do now, I try to send myself the type 0 one, which is, so this is my number, 4917476174228. I guess this is the number, yeah. So I try to send myself the same number. I will show you exactly. I mean, I don't have any other SIM card, otherwise I have showed you from other phone actually. And sometimes they do filter those messages, or maybe it gets blocked by the network, or depending on the traffic, it just gets pipeline, because these are kind of a binary type of SMS. Yeah, so you get 2 notifications, either one, but one was from Hush, the Hush SMS actually was exactly from the type 3 messages, ping 3. And this one shows you alert, like there's some suspicious activity going on. Would you want to enable the flight mode now, because it looks like suspicious? So you click on that message, you get the phone number also, who sent you this SMS and what was the time frame. And the Hush SMS, it also detects, but it doesn't detect the protocol identifier 64-bit, as I said. So it detects you with protocol identifier bit, which is 0 for the ping 3 messages, but type 0, which is used by legal entities, is like 64. There has to be a 64 there. And it doesn't show you the phone number actually, which comes, but this is only for this one, but not for type 0, because there's a reason. These are the messages that always comes into your baseband processor, never comes to Android UI or Android operating system. So that is the difference for that one. So it does detect that one also message now. So this was about detecting these 2 ones. So this is one feature now. And now, can we have slides, please? Yeah. So we continued further with this tool now, how we can enhance to detect IMSI catchers, because now these are the only 2 features. Okay, whatever the calls you made, it just pop-ups, shows you details, and now also silent SMS. Now to detect IMSI catchers, this is really a trivial problem. As I said, it's not that easy. Seems to be easy by reading the recent media articles, but not. So why I'm saying this? This was a manual from one company. So they claim what exactly their tool does actually. So they says automatically scanning and detecting parameters of all 3G networks. So before you deploy any IMSI cacher, it scans whatever the network surrounding it has. It just filters out all the settings. They require essential setting to set up. Like yesterday, the greedy base station guy set up his network as a Vodafone or any network. He has to scan those frequency channels and all those details to do that, right? Jamming 3G selected networks in the working area. So this was the 3G IMSI catcher. So what it does, it also has a jammer. It jams surrounding all 3G networks. Automatically, your phone camps back on a GSM, even though you turn it to the 3G. Of course, if you fix the mode to 3G, it never goes down, but there has to be connectivity always. So this pop-ups for a GSM. And then forcing handsets to migrate to GSM mode, and it makes possible interception of such phones by GSM semi-active or passive interception systems. So this is the manual from one leak version, for this one. So this might be, I don't know, this is one of the feature, at least they say, downgrading attack. But with a femtocell system, it's not really possible. If somebody has a femtocell-based IMSI catcher, which I had on my earlier slide, this is like a tiny iPhone. And surprise, this is the company in UK, actually, which sells this IMSI catcher. Like a tiny, like your iPhone size. This is the only smallest IMSI catcher you can have with the femtocell systems, which is called Athocell, actually. Like you have a femtocell, then this is the smallest femtocell which they created. And they also sell on this point. So this actually works on a 3G network. And if you have that one, there is no way you can detect those kind of base station. There is a way, but it's really difficult because they never force you to go on a GSM. They also track you with a 3G. So you need to have more data. You need to find more parameters to differentiate whether it was a real base station or was it really fake base station. So from last 1.5 years, we were trying to collect different network operators. So whenever I go to any country, I just record the traffic. I analyze, okay, so this belongs to this network, and one parameter was, so whatever the difference we saw so far, this was one field, was saying MSC is a release 99 onwards. What does MSC means? It means mobile switching center. So what is a mobile switching center? So every base station is connected to one server, which is called mobile switching center. For example, in London, for Vodafone, there might be 2 or 3 base stations, mobile switching center, which are totally controlling all the base stations in the city. Might be 3 or 4, because city is pretty big right now, so might be 3 actually. And these are 3 connected to the classical PSTN system. So when you make a phone call to landline anywhere, so these are the places which interconnects your all calls. And these are running a software which has a release version 99 onwards. Every operator has a different configurations. Every operator has a different softwares. Somebody buy from Ericsson, somebody buy from Nokia CMOS network, somebody buy from Huawei, and every software has some parameters. And this is the parameter I get from that MSC actually. And if I get any IMSI catcher, definitely he's using some open source software, or maybe they build their own. So definitely they have different versions running or different parameters. This was we find out actually. But now if there is a guy who is sitting there who builds IMSI catcher, definitely he will go and he will just modify those parameters. That's what I said. It's like a cat and mouse game. Somebody can change parameter easily something. So there has to be a way to do that. Then second one was PWRC, and then there was one radio link timeout. So as I go with this one, so as I already said, MSC, so shows the current GSM network version and what kind of software it was running. I already explained. So this was our data actually. With the telecom in Germany, it was 99 onwards. Basically, most of the recent, big operators had same settings. So this was a play network from, it was from Poland actually. It was 98 or older. Same goes with open now. Yesterday, the guy was running greedy BTS actually. So I asked him whether you really change any parameters while patching a firmware. So OpenBTS, if you just compile and run as it is, it has this setting. So anybody builds any IMSI catcher, he's just using the same stock code actually, which is available in OpenBTS or OpenBSC. So actually his parameter will be same. Nobody will care to change this one. Who knows? But these are kind of parameters we try to detect and try to see there is a difference with that. The second one, as I already said, radio link timeout. So this depends. If your city is too dense, like you have many users camping on a base station, it's good to have a less value so that you can serve more mobile phone. There will be less call dropout. So these are the settings every operator does depending on the area, depending on the time. And when we analyze those packets, the telecom in Germany, at least in Berlin, they had a 64-bit. O2, same in Berlin, has a 24. Vodafone in UK also has a 64, Play Network 64. This was the BSNL from India. Also, this was Idea, which is operated in India, has a 40. We collected more data, but you see a difference actually with those parameters. And this really varies between a city. I really cannot say based on this parameter whether this is the fake base station or whatever it is. But this is just try to give a more intelligence what's really happening there. Last is about power control indicator. This is about base station asks you whether you should provide the power measurements from your mobile device to the network. What exactly the power it has right now? What is the power measurement? And also, there is only true fields, true or false, but there is also, we saw some variations. Some operator does it, some operator doesn't. So telecom in Germany was false, but now we did actually in Vodafone here, they have a true. We don't know, I mean, these are just parameters, they change, or we found different parameters. Now, and based on those parameters, we tried to build a profile. So how does it look like? So what this tool does, if you install this app actually on your phone, like 2 days you use this app, you travel to your office and building, it just creates, records all those messages, save in a database. In 2 days, it will just give you pop-up message, hey, your location area changed, there is a new profile, there is new something. It collects all this information and store in the database. And now if you go next day to Paris, as soon as you land, you turn on your mobile, it will immediately pop up. Hey, doesn't look like you are in London, right? I mean, of course, roaming parameter, but it checks all these parameters again, saying that, okay, there is a new profile for you now. And now this is good if you don't move anywhere, but you come to house and immediately profile changed. Last 2 days, you didn't get a notification, and third day, you are getting suddenly a notification. Now, okay, something is changed, but you did not move at all from your house, right? So this is like kind of a suspicious indicator to try to give you, maybe. And this is just indication, okay, something is wrong, just turn off your phone or use some other mechanism to make a call. Just something is like, about some interesting data, what we collected like last 2 days, as I said, for a demo, I was trying some SIM cards yesterday. So we bought some SIM card and let's test out some IMSI catches, sending a type 0 silent SMS or something. So this was, last one is Vodafone UK calls. So we made 10 calls. Like few calls, SMS, 3G, GSM, and this is a Libara UK. Of course, this was the cheapest I could bought from a store actually, because I go and ask the other SIM card, they said you need identity and some, of course, it's expensive. So surprising thing is that the Libera SIM card, which most of the foreigners use while coming in London, at least for a cheap calls, the network is also provided by Vodafone. Both SIM card were operated by Vodafone. So when I make a call, you see here that all my calls were authenticated, even the incoming and outgoing. But when I was using a Libera card, 80% call were not authenticated, even the incoming and outgoing. I don't know why it's differentiation. So the preference goes for the real Vodafone customers. So Libera means virtual mobile operator. There might be more actually in UK. Now, if you use those operators, actually their settings are not really secured. And there is a really clear differentiation by the real operator to give those services. So if you really buy any such kind of cheap SIM card for, like for less services, might be you have a real different security settings. I mean, you could ask this question to the operator, why this is happening. I mean, why you are treating like this for the security of different customers, right? And if your incoming calls like this one is not authenticated, what does it mean? There was a recent attacks from our group. There was a guy, 2 guys, Nico and Kevin, they did research on GSM. If your incoming call is not authenticated actually, especially GSM, not authenticated, it means that with a modified Osmocom tool or some special tools, they can take your call before you take the call, because there is no authentication that where this is the UGAR. And they did a demo. I mean, still the paper is available for you to read if you want. They grabbed your SMS before you. So if you get SMS like a banking SMS, your MTAN is this one, they grab this SMS before your mobile phone get this one. This happens if your operator is not doing proper authentication for the incoming calls. Of course, you cannot do for outgoing because the call was authenticated. And if you are authenticated, this is not possible. And this has been shown actually one time. Also, outgoing call is not authenticated. Somebody can spoof you. I have a special tool, and I can put your IMSI number, TIMSI number on my settings, and I can make a call on behalf of you saying, this was my TIMSI. And if this goes in a code, like you did some bad activity, lawful interception system says that this TIMSI belongs to you. And actually, by record, you are the victim, but not. This guy was making a call on behalf of you because call was not authenticated. Technically, this is possible. I mean, currently, this is possible. And this has been shown in practice. And this was the behavior we found. And there was also one more result. While I was coming here, I came from Switzerland, actually, right? So I was on a train. So I was trying to make a call. So I was bored on a train. I made plenty of calls and see, OK, what's happening. Now, notice one thing. The red dot means A51 algorithm, and this green means A53. Most of the European operators have updated their algorithm. They are using A53, which is at least so far we don't know any proof that it can be broken. But in UK, Vodafone, T-Mobile UK also, T-Mobile Germany use A53, but T-Mobile UK use A51. We don't know. Same goes with Vodafone. Vodafone use A51 here, and in Germany, some network they have upgraded to use A53. I don't know why they have not upgraded all their algorithms like this, but this might be a question to ask all the guys. And there was one thing actually, one parameter. You see, one call was not encrypted actually. It was authenticated, but it was not encrypted. Authentication can be fake. The fake base station can force you not to authenticate, but this can happen. Now, if I use this media, like if you read the article about this fake base station and they say you get a pop-up notification, your call was not encrypted, so there might be fake activity. But this is not true, because I was in a train was going some maybe 70 kilometers per hour or 80 kilometers per hour, so I was changing a location area or base station like with a speed, right? So what happens, sometimes your call messages get dropped. Okay, your messages get dropped, right? And then actually you cannot have a proper settings. So sometimes base station decide, okay, don't use encryption for this guy because his location is changing pretty frequently. So this was actually a problem from the network side. So there was no IMSI catcher. So actually you really cannot say with that message that, oh, okay, this was the fake base station. This is just to highlight you that some media people says, okay, this was the thing. Of course, the GSMK guys do more than that. Actually, definitely I agree, but this is not the only indicator to tell you that whether you are a fake base station or not. I think they said our time is up, but there was one thing I just wanted to mention, or we want to release a tool. I just take a few minutes actually. There was just one demo we want to make, and last Black Hat I showed about this point, and I never released this information because this might be suspicious. What is it actually? Every phone, what happens, I just skip this slide. So what happened, if you see this base station and there are two guys, instead of Elias Bob, I just use Angela Merkel and Obama actually. So for example, Obama is calling Merkel right now. So hey, I want to talk to you. So what happens when he calls him, his calls get diverted from here to his mobile phone. And what base station does, it page your device. It means it has to say hi. And in GSM, the method of saying hi is either send your TIMSI number or the IMSI number for your SIM card to recognize whether you are in this area. But while happening this, these hi messages are always in the air. If you have a proper device, you can cache those messages. So Darshak has a capability to do that. I mean, at least this phone allows me to do that. So what our new app, which we're not going to release because it has a bad purpose, it also detects these two numbers. This belongs to Obama, this belongs to Merkel, and I can see those messages, two messages. What does it mean actually, or what I can do bad purpose with this one? Now, as I said, there is a silent SMS, so I just quickly show you the demo and I finish my talk. So I quickly turn off. I stop the app. Yeah. It is stopped. I open a new app. It's called TIMSI phishing because basically we try to locate some guy actually. So what I do, I say is begin just to initiate the thing. It's collecting the state of log. I just waiting for one message. Yeah, exactly. It's starting now. So what I will do now, instead of sending a silent SMS, because as I said, I don't have a capability to send silent SMS because I'm on a Vodafone network, I just give a few missed calls to this number, like 5 calls, for example. You want to run Darshak? Okay, no. So because we don't have a time, I just run the demo, but if you want, I can just show you the more proof how exactly we are doing that. So that was the first call. I just give 3 calls, and I just show you what exactly the result comes out. Could you cut the call? Yeah, this was the first one. This was the second one. And actually, we can do also with other phone, but right now we don't have a setup or other SIM cards to do that. So basically, I call with the 2 phones, and this is the special phone which is try to detect this. This can be anywhere in the room, actually, the third phone. So this was the second call. So let's do only with the 2 calls, and I will show you the result and what does it mean actually. So I say is calculate IMSI. So it process whatever the packets he got from different phones and try to see how many times I page one single number. So there has to be a frequencies of collection. Okay, as usual, it didn't work out. But okay, we are running with the time, so I will show you again. So what it exactly does, it collects all the IMSIs. So I call this guy now 2 times. So method is, all the agencies use this method. There is a special device called string ray or something, which is the identifier for you. So they sent you 10 silent SMS for this guy. This guy never get notifies that he's tracked. What happens, the device is running in this some proximity area. It detects that your mobile phone number paged for 10 times. So they will get in a pop-up as a screen, 10 times one IMSI number is get a pop. Okay, so this was the right guy, we were talking to him, and this is in this area right now. And we don't have the ability to tell you the location. So there are some special tools which also tells you the direction. He's in this area, he's in this area. You might have seen this Hollywood movie. On the map, it just pop up. So this red dot belongs to this guy. So this guy is in this building right now. So actually, we also have this capability, not telling the building, but at least we tell you that this belongs to this location area, like particular which area. The distance could be 1 kilometer or 2 kilometers. So I can tell you any guy which is exactly in 1 kilometer or 2 kilometer with this tool. Of course, we're not going to release, but this has that kind of implications. But we can do more than that with Darshak. That's why we release the source code. So if you are interested to do something more, actually detecting base stations or try to play more around with the GSM or trying to detect suspicious behavior, we are open to have any suggestions or anything. So thank you for your time. And if you're interested, I can show you the demo again, right? Sorry for that. Thank you.